Hello, my name is Taylor Ross. I'm an Aximmetry ambassador and the owner of Frustum Virtual in Los Angeles, California. In this tutorial, I'll show you how to set up the AR workflow in Aximmetry DE. AR stands for Augmented Reality. In virtual production, this is the technique of compositing the studio's camera image with virtual objects. So the first thing we need to do is open the Unreal Editor for Aximmetry. This is Unreal Editor for Aximmetry 2024.1.0. So the first thing you'll see is the Unreal Engine project browser. This is where all of the Unreal Engine projects that you've created in Unreal Engine from Epic Games or Unreal Engine from Aximmetry will be located. I've already created a project called Aximmetry AR01 in the Unreal Engine from Epic Games. The only thing I've done in this project is add a few elements from the Epic Games Marketplace that I want to turn into AR elements. With the Aximmetry AR project selected, I will select Open at the bottom of the Unreal Project browser. Once I select Open, it will prompt me to convert the project. This will open a copy of the project that will make sure we're not doing anything destructive to the original version we created with the Epic Games version of Unreal Engine. So I will just select Open a Copy. Once the project opens, you should see that it looks exactly like the Unreal Engine from Epic Games. My layout may look a little bit different than the native Unreal Engine 5 version. You can change your user interface layout to look like mine by going to Window, Load Layout, UE4 Classic Layout. This will put Place Actors on the left-hand side. It will also create a dock at the bottom. I will also dock my content browser here. So I will go to Window, Content Browser, select Content Browser 1. I'll grab the Content Browser tab and drag it down to the dock. The Content Browser is pretty much the same as this content drawer. I just prefer this workflow because it's easier for me to see my content. Again, this step isn't necessary, but if you want your layout to look like mine for this tutorial, that's how you do it. Now that my layout is set up the way that I like it, we need to change our scene settings. So we'll go to Edit, Project Settings. There's a lot of project settings that need to be changed for the AR workflow. In the Search tab of our project settings, we're going to type in Pixel Format. We need to change the frame buffer pixel format to float RGBA. Once we change this setting, you'll see Restart required to apply new settings in the bottom right-hand corner. We'll leave this alone for now because we need to change a few more settings before we restart our project. Next, we need to change the custom depth stencil path. So we'll type in stencil in the search bar. We'll select this dropdown and change it from enabled to enabled with stencil. Next, we need to enable planar reflections. So we will type in global clip plane in the search bar. Under reflections, we're going to turn on support global clip plane for planar reflections. Just check this little box to make it true. Now we're going to make sure that our project doesn't have motion blur. Just type in motion blur in the search bar. Just make sure this is set to false, so we don't want that checked. Now in the search bar, we'll look for post-processing. Look for enabled alpha channel support in post-processing. Change this from linear color space only to allow through tone mapper. Now we'll navigate to the project settings, select maps and modes on the left-hand side. We need to make sure that the game default map and the editor's startup map are both set to the map that we're currently working on. If we look at our outliner, you can see the name of the map that we're working on. So my editor's startup map is already set to main. For the game default map, I'll search main and then select it. Next, we need to change the game default mode. If you don't see the game default mode, use this dropdown. We're going to change this from game mode base. Select this plus icon to create a new game mode. Rename this game mode to Aximmetry mode. Once we're happy with the name, we can select save. Navigate to default pawn class and select none. Now on the left-hand side in our engine settings, we're looking for input. Select input. Scroll all the way down in our input settings until we find mobile. Look for the default touch interface. Use this dropdown and just select clear. We also want to turn off always show touch interface and show console on 4-finger tap. These settings are turned off to make sure that we don't have any touch interface overlays when we're simulating our game. Now on the left-hand side, we'll scroll back up to our project settings and select packaging. At the bottom of our packaging settings, we'll find an advanced tab. Go ahead and drop that down. In these advanced settings, we're looking for list of maps to include in package build. We'll select this little plus sign. This will add a new index. Now we'll use these 3 dots to browse to the location of this project. By default, the project should be located in your Documents folder, Unreal Projects. Now we're looking for the Aximmetry AR01 with a 5.3 at the end. We don't want to select the Unreal Engine project file. We want to navigate to our Content folder. In the Content folder, we need to find the name of our current map. Once you locate the map that you're currently working on, you will select it. We can now close our project settings. By selecting this map in the list of maps to include in package build, we will only be cooking this map. This will save a lot of time during the cooking process. You will only be cooking the map that you're currently working on. Now we'll select Restart Project, select Save Selected if you haven't already. Our project will now reopen with all of these settings saved. Once the Unreal Editor for Aximmetry finally reopens, it may look a little bit different. Seems a little bit lighter gray. This is because of some of the project settings that we changed. Now that all of our project settings are correct, we need to add the Aximmetry AR camera. So we'll go to this Aximmetry tab, go to Add Camera, and then select AR Camera Tracked. Once this camera is added to our scene, you will see that it is placed at World 0. You can reposition this camera if you'd like. Just take note of this World 0 point because when you open this project in Aximmetry DE, you will start here. Next, we need to make sure that we don't have a player start in our world outliner. The player start is represented by this game controller at World 0. If we don't delete the player start, it will render as a sphere in Aximmetry DE Composer. If you don't want to delete the player start, you can just move it to a position that the camera will not see. I almost always just delete the player start so I don't have to worry about it. Now we're ready to add all of our AR elements. When I created this project in Unreal Engine from Epic Games, I added this Valkyrie that I downloaded from the Epic Games Marketplace. This is just a cool character that I thought would be great for a tutorial example. It's a little bit more dynamic than just a basic mesh, which I will also add here in a moment. In the Valkyrie folder, I'll navigate to this Animations folder. I'll select Blueprints, BP, and then I'll find the animation that I want to add. I'll just drag it into my Unreal scene. I will then rotate this animation 180 degrees so that it's looking at this camera. I'll make some quick adjustments to the location transform, just zeroing it out and putting it at the 0 point of our Unreal world. I will now place this a little bit further away from the camera. Most likely in your scene it will be a little bit different than what I'm doing. I will also navigate to the shapes in my Place Actors tab, and I'll add a cube. I'll make a few quick adjustments to this cube. Now I'll add a cone just by dragging it into our Unreal scene. These are all just examples. I know that the project that you're working on will most likely be different than mine. Now that I'm happy with the placement of all of my objects, I'll navigate back to my world outliner and select the Valkyrie animation that I added. Now in the details panel below, in the search bar, I'll type in tag. Under actor, we will find tags. Select the plus sign next to array elements. For index 0, we're going to write in the tag Aximmetry AR. By adding this tag, Aximmetry will know that this is our AR element. So in the actor section of all of the elements that we want to be AR elements, we need to add this tag. So I'll go to the cone. Now we'll do the same thing here. Actors, tags, we'll select the plus sign. Index 0, we'll add Aximmetry AR. Finally, back in the world outliner, I'll select my cube, go to the tag, add the tag Aximmetry AR. So for the final step in this scene, I'm just going to start deleting some of the things that will cause issues when we open this in Aximmetry DE Composer. You can experiment with keeping or deleting some of the things in the scene. I've found that the main thing I want to keep is this light source. So I'll delete this instanced foliage actor, the atmospheric fog, the sky sphere, the skylight, the sphere reflection capture. You can experiment with the elements that you want to keep. I've just found that for most AR scenes, you only want to keep your AR elements and the lighting that's needed to light those elements. Again, you'll just have to experiment with what it looks like when you open it in Aximmetry DE. Ideally, your AR scene will only have your AR elements and the lighting that's needed to light those elements. Now I'm going to make some adjustments to my light source, so I'm just going to rotate it to be more of a backlight. I'll adjust the angle a bit so that I don't have such a long shadow. I'll make a few more quick adjustments to my AR elements. I'll navigate to my Place Actors tab. I'll add a point light to get a little bit more detail out of this Valkyrie. Now I'm going to make some adjustments to my point light. I'll use temperature and change this to 4000 to make it a little bit warmer. I'll adjust this light a little bit further. Maybe change the attention radius to 200. Let's try 500. Your settings will most likely be different. I'm just kind of showing my workflow here. Just trying to get detail out of my AR elements. Now that I'm happy with this basic lighting setup for my AR elements, I'm just going to show you a few more of the functions that come with this AR camera. I'll navigate back to my content folder, open the Aximmetry Tracked Cam AR folder, open the Blueprints folder. In the Blueprints folder, there's an Aximmetry shadow catcher. I'll click and drag the shadow catcher directly into my scene. The shadow catcher will add shadows to our AR elements. I'm going to scale this shadow catcher up until I can see the entire shadow from my AR element. I found that I almost always need shadows. In the Blueprints folder, there's also a Aximmetry reflection catcher. If your AR elements need reflections in the physical world, you would use this reflection catcher. The reflection catcher is very processor intensive, so you can only add 3 of these. I know that my physical world will not need reflections, so I'll go ahead and delete this reflection catcher. You will just have to experiment with what looks best for your scene. I'm pretty satisfied with the way that my scene is set up, and your scene should look similar. There will be a lot of troubleshooting that you'll have to go through depending on the elements that you want to be AR elements, but that's all stuff that can be done once we open this project in Aximmetry DE Composer. I'm just going to make a few more adjustments to my lighting. As a final step, I like to select my Aximmetry AR tracked camera. Moving the camera to this perspective in my editor will give me a general idea of what it'll look like in Aximmetry. I'll just rotate my camera slightly left and right to see all of my AR elements. Placing the Aximmetry AR camera in a specific position in the Unreal Editor doesn't really matter because we'll always start at world 0. It's important to know where the world 0 is of your scene because this is where you will start in Aximmetry DE. Since this camera has camera tracking, you will be offset automatically. I know that this is the general area where my camera will end up, so I'll just place it here to get a better understanding of what my scene will look like. For the final step, we're going to navigate back to our Aximmetry tab and then select Cook Content for Aximmetry DE. I will open my output log to watch the cooking process. I can also select Show Output Log in the lower right-hand corner. Depending on how big your scene is, this could take a lot of time. When we were setting up our project settings and I went to Packaging, List of Maps to Include, and Package Build, I basically told my Unreal Engine project that I only want to cook this map. By telling the Unreal Editor to only cook this map, it should greatly increase the speed of your cooking process. So now we just have to wait for the cooking process to complete. I'm just going to fast forward this process so that we don't have to sit here for very long. Once the cooking process is finished, you'll see a build successful at the bottom. If you have any errors while cooking your project, it will be in red and it will say build failed. If this happens, you'll just have to address this issue. You'll be able to go through all of this dialogue and find out exactly what went wrong, and then you'll just have to address that issue and try and cook again. My cooking process was successful, so I'm just going to go ahead and save my entire project. Select Save All in the bottom right-hand corner or this little save icon in the top left. Once the project is saved, we can just close the Unreal Editor for Aximmetry. Once we have everything set up in the Unreal Editor for Aximmetry, we're going to go ahead and open Aximmetry DE Composer. So I'll open this. I have the broadcast license. The first thing you'll see is the Aximmetry Composer startup configuration. This is the video outputs page. This is where we'll map our video output devices. I have 2 desktop monitors and 1 SDI output. On the right-hand side, this is where you'll index all of your video outputs. I'll set my secondary desktop monitor to index 1 and my SDI output to index 2. Next to my SDI output, under Mode, I can change the resolution and frame rate with these 3 dots. So for my final pixel output, my resolution will be UHD 2160 and my frame rate will be 24 frames per second. For the frame rate, you just want to make sure that you're capturing at the current frame rate of your camera. Once this is set, you can just select OK. With my video output devices set to the proper indexes, I will navigate to the left-hand side and select Device Mapper. Now on the Device Mapper page in the Category section, we will find the Camera Tracking tab and select it. With Camera Tracking selected, we will select Manage Devices. We'll scroll down on the left-hand side until we find Game. We have OpenVR and Anti-Latency. OpenVR is the HTC Vive system. Anti-latency is the anti-latency system. I'm using the anti-latency system, so with anti-latency selected, I will use this drop-down to find the device that's currently connected to my computer. If you're using any other camera tracking solution, it will be located in the camera tracking section. Since I'm using anti-latency, I'll just select my device, and then I'll go ahead and select OK. Next, we'll set up our zoom encoder. Select zoom encoder and then go to Manage Devices. On the left-hand side, we'll scroll down until we see zoom encoder. I'm using the LowNet 2. If this is the first time setting up your zoom encoder, this section will be blank. If this is blank, just select this Add button. And then in the Add LowNet 2 channel, you just need to make sure that the UDP port and Join Multicast group match your LowNet server. I will quickly open my LowNet 2 server to check my UDP port and multicast group. Everything looks correct, so I will minimize my LowNet 2 server. Now in the Add LowNet 2 channel, I will just select OK. With the channel created, I will select OK. If I wanted to create a preset for either my camera tracking or zoom encoding, I would use this dropdown and then select the device. This would create a preset that loads when we open Aximmetry. For now, I'll leave this blank so that you can see how to set it up once we're already in Aximmetry DE Composer. The final step, I'll go back to Video Outputs. Just make sure that everything is correct here, and then I'll hit Apply and Start. Once Aximmetry DE Composer opens, you should see a blank sequence editor. The first thing I like to do is make sure that my preferences are correct. So I'll navigate to Edit, Preferences. In the rendering section of our preferences, you can select the frame size and frame rate. So for the frame rate, I'm at 24 frames per second. Make sure that this matches what your camera is currently recording at. And for the frame size, I have it set to 1920 by 1080. You can change the frame size to whatever you'd like. Just note that this frame size setting can affect your processor load. So depending on what you set this at, if you go to UHD or 8K, you may notice that it's impacting your GPU. So if you notice that your GPU is taking a big hit, you may want to adjust your frame size depending on what your system can handle. For this tutorial, I'll just leave it at 1920 by 1080. But you can experiment with this frame size setting in your own project. You just want to make sure that your frame rate is matched to what your camera is currently recording at. Now that my frame size and frame rate are set to the correct settings, I'll just hit Apply and OK. The next thing we need to do is add a new compound, so we'll come up here to New, Compound, or Control-N on the keyboard. This is my blank new compound. Now we need to add the camera. So on the left-hand side under Projects, we'll open Common Studio, Camera. Here we have all of the different cameras that can be added to our Unreal scene. So I'll find the camera that I added to my custom Unreal project, which is this ARCam Unreal. I'll open that folder. You'll see ARCam Unreal 3, 4, and 8. This is just the number of cameras that will be added with this camera type. For this tutorial, I'll add the ARCam Unreal 3 cam. I will click and drag this camera directly into my compound and let go. This will add the ARCam Unreal 3 cam to my compound. You'll also notice at the top that it's added 2 new tabs for camera and inputs. Now we need to add our custom Unreal project, so we'll just browse to the location of our Unreal project. By default, this is in Documents, Unreal Projects. My project is called Aximmetry AR01 with a 5.3 at the end. The 5.3 is the copy that we created at the beginning of this tutorial. Now I'll just find my Unreal project, and I'll just click and drag that directly into my compound. In the processor load in the bottom right-hand corner, you'll see that it is loading. Once it loads, you'll see pins on the left-hand side of our Unreal project that match the pins on the right-hand side of our ARCam Unreal 3 cam. We just need to click and drag to connect the pins with the corresponding names. So for these 2 nodes, it would be from outsize to outsize and from control data to control data. Now on the right-hand side of our Unreal project, we're going to click and drag from these pins to the pins on the left-hand side of our Unreal camera. So we'll click and drag from out to rendered, reflection 1 to reflection 1, reflection 2 to reflection 2, reflection 3 to reflection 3, shadow to shadow, shadow clean plate to shadow clean plate. Once our nodes are completely connected, we'll click and drag from preview to the output bar on the right. We'll also click and drag from out to the output bar on the right. Once these outputs are connected, you'll have the option to rename the pin. I'll just leave this pin name as out and select OK. Down at the bottom, Preview 1 and 2 should have been updated. Preview 1 is my secondary monitor, and Preview 2 is my SDI output. In both of my preview monitors, I have device not found. This is because I didn't set up any presets at the beginning of this section of the tutorial. Before I set up my inputs, I'll navigate to the Cameras tab at the top. In the Cameras tab, we have the option to select between camera 1, 2, and 3. This corresponds to our inputs, input 1, input 2, or input 3. So you will want to select the camera that you are currently working on, and then you can set up the inputs in the Inputs tab. Before I go to the Inputs tab, I want to explain the rest of these settings in the Cameras tab. In the Camera Mode square, we have this mouse. This will give us the ability to move around our scene outside the view of our camera. Clicking and holding the left mouse button gives you the ability to pan and tilt. The middle mouse button lets you jib up and down or left and right. Your right mouse button lets you dolly in and out or left and right. This is more useful in the virtual camera mode of Aximmetry. In the AR camera mode of Aximmetry, this mouse camera mode is the only way that you can use this function, but it's really limited in that it only lets you move around your 3D scene, not adjust the placement of your camera. I will go back to my final render view represented by this camera. Below our camera mode, we have our preview monitor output. The matrix will show us all of our cameras. From this view in our preview monitor, we can see our program, camera 1, 2, and 3. To see only the feed of our individual cameras, we can just select them in this preview monitor output. I will reselect program to see my final output. In this on-screen tab, you can see your info, safe, and SDI. This will only be visible in your Preview 1 output. You can also turn on and off streaming from this Cameras tab. I will cover streaming functions in another tutorial. Now that I've covered all of the settings in the Cameras tab, I will make sure that Camera 1 is selected, and then I will navigate to the top and select Inputs. In the Inputs tab, find the square labeled Input 1 and select it. This will give you access to all of the settings for Input 1 on the right-hand side. Starting at the top of this list, Camera Device, I will select this dropdown and then select Blackmagic Decklink AK Pro 1, which is where my live camera feed is coming in. With this selected, you should be able to see my live camera feed in Preview 1 and Preview 2. Next, I will navigate to Camera Mode. Use these 3 dots to select the resolution and frame rate of your incoming camera feed. I know that my camera is sending a 1080 signal at 24 frames per second, so I will specify that here and then select OK. Next, under Tracking Device, I will select my Game Anti-Latency Device 0. If I would have set up a preset, this would already be mapped, but since I didn't set up a preset, this was left blank. Now for the calibration profile, I will select these 3 dots and then find the calibration profile for this lens. This calibration profile was created in the calibration tutorial, so I will select that and then press OK. Once the correct calibration profile is selected, it will update in my Preview 1 and 2. For the zoom device, I'm going to select my Lonet 2. Currently, the AR elements in our scene will not be affected by the focus of our physical camera. The zoom device also handles the focus encoding. Our focus calibration was set up in the basic calibrator tutorial. Since our AR elements will not be affected by the focus of our lens, I won't worry too much about this setting. Now that our main input settings are set up, I will select the origin square. You can see in Preview 1 and 2 that I have an Aruco marker placed on the floor. This Aruco marker will tell Aximmetry where I want the origin of my scene. I found the link to this Aruco marker on the Aximmetry website. You can generate the Aruco marker from this URL. Just make sure that you're using these specific Aruco marker settings. After I downloaded and printed this Aruco marker, I placed it in the center of my tracking volume. With the Aruco marker in the view of my camera and the origin 1 square selected, I will select this trigger function next to Detect Origin. This will place the origin of my scene at the center of the Aruco marker. You can see this offset has updated in the Delta Cam transform. Now I will reselect Input 1. Now I'll cover the rest of the Input 1 settings on the right-hand side. For this tutorial, I'm not going to change a lot of these settings, but you can experiment with them in your own project. We have tracking forward port, use audio device, timecode master, in color space, in gamma curve, chroma offset, no input image. We have a manual lens setting. If we turn this on, this manual lens setting would be used if we didn't set up a calibration profile. So basically using this manual zoom setting with the manual lens turned on, we have the ability to match the focal length of our physical camera. It is possible to match the focal length of your physical camera. It's just a lot more difficult and a lot more time consuming to do it this way. I would recommend going through the calibration process because the result that you will get at the end is a lot more robust. In a physical production environment, you want to eliminate as many variables as possible. Next, we have manual focus. The focus won't affect our AR objects, so you don't really need to worry about this setting. With manual focus selected, I will hit Ctrl Q on my keyboard to reset it to 0. Now I will select manual zoom and hit Ctrl Q on my keyboard to reset it to 1. I'll go ahead and turn off this manual lens setting because I have a calibration profile. Next, we have external lens data. I will leave this turned on. Below that, we have camera delay. This would be used to delay the incoming live camera feed. In most circumstances, the camera tracking data will be coming in faster than the live camera feed. So we almost always want to leave the camera delay at 0 and adjust our tracking delay rather than our camera delay. Next, we have timecode sync and zoom timecode sync. Below zoom timecode sync, we have detect tracking delay and detect zoom delay. These functions will auto-detect our delays for us. I will turn on detect tracking delay. Aximmetry will ask me to place a distinct red marker. I'm using red tape to hold down my Aruco marker, so you can see that Aximmetry has found one of these red pieces of tape displayed by this little white X. And now Aximmetry is asking me to rotate the camera left and right, panning. You want to make sure that you're not tilting during this process. So now when I pan my camera back and forth, Aximmetry will auto-detect the tracking delay between my camera feed and my tracking data. I'm just going to reposition my camera so I have a better view of this red mark, and then I will pan my camera left and right. Once Aximmetry finds my tracking delay, it will notify me. It will say delay found in set 2.6 frames, or however many frames your delay is. Once the tracking delay is detected, it will be reflected in the input settings on the right. You can see here my tracking delay is now set to 2.6 frames. As a quick example of what it should look like when your tracking delay is set properly, I will pan and tilt my camera back and forth. You will see the center point of my tracking volume sticks to the center point of this Aruco marker. There should be no significant sliding or drifting in your tracking data once the tracking delay has been set properly. Now that we've detected our tracking delay, I will explain the zoom delay. Just like with the tracking delay, we have an auto-detect function for our zoom delay. I'm not using a zoom lens, but I will quickly turn this on so you can see how Aximmetry will act. Just like with the detect tracking delay function, Aximmetry will ask you to place a distinct red marker. Once Aximmetry detects the red marker, it will ask you to slowly zoom in and out. I will turn this function off since I'm not using a zoom lens. Below the delay settings, we have a tracking dejitter. Tracking dejitter is used to remove any jitter that your tracking volume might have while your camera is still. So if you notice any jumping around in your tracking volume when your camera is not moving, you can use the tracking dejitter setting to try and remove some of it. Now that I've explained all of the input settings, I'm going to navigate to my scene tab. I'll select it to expose all of the settings for my scene. The first scene setting that you will see is the Basecam transform. This will adjust the position of your 3D scene. Below that, we have scene scale, which will adjust the scale of your 3D scene. I will leave lens distortion turned on. Next, we have edge expand. I will reposition my camera so that you can see my AR elements. Now that my AR elements are in the view of the physical camera, you will be able to see what this edge expand setting does. In preview 1 and 2, you can see that there's a tiny gap between my AR element and the edge of my frame. Using the edge expand setting, I will be able to adjust for this gap. I will navigate to this edge expand setting and increase this to 0.03. The edge expand setting expands the edges of our composited image. I've found that the value of 0.03 takes care of this little gap. Since this setting is expanding the edges of our entire composited image, it is very processor intensive. You want to move this up in small increments. The higher you set this value, the harder it will hit your processor. This gap is created by the calibration profile of our camera. I'm using vintage prime lenses, which have a lot of distortion. Your calibration profile may not have this issue. Luckily, it can be easily fixed with the edge expand setting. Next to our scene tab, we have catchers, tone map, glares, and adjuster. If I select the node labeled catchers, you will see all of the catcher settings on the right. The catcher settings correspond to the reflection and shadow catchers that we placed in Unreal Engine. In order to showcase this, I will tilt down to show you the AR shadows, and then I will adjust this shadow strength. In preview 1 and 2, you can now see the shadows that are created by my AR elements. I will slowly drag the shadow strength down. You can see that as I adjust the shadow strength, the opacity of my shadow becomes lighter. Adjusting the catcher settings allows you to blend your AR objects, shadows, and reflections into your physical scene. You will have to experiment with what looks best for your scene. In my opinion, this is one of the easiest ways to add realism to your AR elements in your physical scene. As I mentioned before, you can only add 3 reflection catchers. This is because the reflection catcher is a very processor-intensive element. You will notice in your processor load that the GPU and frames per second will take a large hit depending on how many reflection catchers you have in your scene. Next to catchers, we have Tone Mapper. The Tone Mapper settings will handle some of the color correction of your AR elements. If I adjust the exposure setting to 0.5, you will see that my AR element is a little bit darker. The Tone Mapper setting is very useful if we only want to adjust the color correction of our AR elements. There are a few more Tone Mapper settings that you can experiment with in your project. You'll just have to find what looks best for your scene. Next to Tone Mappers, we have glares. The glares are additional effects that can be added to blend your AR elements to your physical scene. Again, these are settings that you'll have to experiment with to find out what looks best for your scene. You can easily turn these effects on and off using these sliders. I'm not going to go into depth about what these effects do in this tutorial, but you can experiment in your own project. Next to glares, we have adjuster. I will quickly adjust the brightness value to 0.5. I like to think of this as a global adjuster for both my AR elements and my live camera feed. We also have an adjuster 1 next to input 1. This adjuster will only affect the live camera feed and not our AR elements. I will use adjuster 1 to only affect the live camera feed and not my AR elements. Just remember that the adjuster labeled adjuster is the global adjuster and that adjuster 1 is for our live camera feed. So Tone Mapper is our AR elements, adjuster 1 is our live camera feed, and then we have our global adjuster. I'll quickly reset my adjuster 1 brightness to 1. You should now have a better understanding of how all of these nodes work. Feel free to experiment with all of these settings in your own project. The last thing I'll show you in this section of the tutorial is how to adjust the position of your AR elements. To do this, you don't want to use the Scene Basecam transform. You can adjust the position of your AR elements using this Basecam transform setting. I recommend that you place your AR elements in your Unreal scene. So to do this, I'll go to my Flow tab. In my Flow tab, I'll go and select the Aximmetry AR01 Unreal project. This is the Unreal project that we brought in. On the right-hand side, we'll see the settings for this Unreal project. Right now, my connection type is set to cooked. If I use this dropdown and then select Live Sync, give it a moment to load. In my Preview 1 and 2, you'll see that Aximmetry is asking me to press play in Unreal Editor. So we need to open our Aximmetry AR01 project in the Unreal Editor for Aximmetry. I already have that project open. I'll just reposition my viewport a little bit here. You can see this is where we left off at the beginning of the tutorial. This is the current position of my AR character. First, let me explain what Aximmetry is asking for. It's saying press play in Unreal Editor. On the Unreal Engine side, we have the ability to simulate the game using this green play button. I can also simulate in a new editor window using these 3 dots. I'm going to leave it in this selected viewport. Now I'll just hit play. Once we press play, Unreal Editor will be simulating the game. It will be reflecting what Aximmetry sees. So you can see in Aximmetry, we only see the feet. That should match on the Unreal Engine side. Now that you can see how the live sync mode works, I'll go back to my Unreal Editor. I'll select this red stop to stop the simulation. Now you can see how I would make real-time adjustments, so I'll reselect my character and move it down. I'll simulate the game. And then back in Aximmetry, you can see that the position of my character has been updated just the way that we made the update in Unreal. So I'll stop this simulation again. So just to clarify, I would highly recommend that you make all of your adjustments in the Unreal Engine side. So if I want to move my character further away, I can do that. Select play to simulate and stop to stop. I need to move the floor back so that it doesn't fall. Now when I simulate again, you can see that those updates are being made in real time. Say I want to Command Z that all the way back to where it was. Hit play again. We're back where we started. You can even move your camera in real time to see it update in Unreal Engine. So I'll tilt my camera up so that we can see our 3D character. The live sync mode is very effective in terms of speed, but the visual fidelity will not be as good as the quality that you will get when you cook the content. So I don't recommend that you run your entire project in live sync mode. I only recommend that you make changes to your Unreal scene in live sync and then go back through and recook your content when you're ready to go into production. Once we're happy with all the adjustments that we've made in Unreal Engine, we can go back to our Aximmetry project. Select the Unreal Project node, change the connection type to cooked. You'll see it loading in the bottom right-hand corner. This will reload the most recently cooked version of your Unreal project. I will navigate back to my Unreal project with all of the changes that I've made. I'll select Aximmetry at the top, and then I'll select Cook Content for Aximmetry DE. Once this cooking process starts, we'll go back to our Aximmetry DE. You'll see in our messages that it's waiting for Unreal to finish cooking the project. And once it finishes cooking the project, which I showed you in this output log, it'll say Cooking Content for Windows in the bottom right-hand corner. We've got the cook command completed, build successful. We can now navigate back to our Aximmetry project. In the lower right-hand corner, it's now loading that cook. Now all of the changes should be updated and we don't need to be in live sync mode. This will just give you better overall visual fidelity. So again, I recommend that you make your changes in live sync, but you don't run your project in live sync. Finally, I'll go ahead and save my Aximmetry project. And then I'll just close Aximmetry. Hopefully this video helped you understand the AR workflow in Aximmetry DE. Be sure to like and subscribe for more videos, and thanks for watching.